Hi, today we are looking at the triangle inequality theorem and how that's going to help us make a triangle. What the triangle inequality theorem is it says that the sum, so when we add any two sides of a triangle, that sum is going to be greater than the third side. So a triangle, tri means three, we have three sides. When I add up two sides of the triangle, it has to be greater than the third side. So here we have sides of 4, 6, and 9. I take two of them. 4 plus 6 has to be greater than 9. 4 plus 6, that's 10. That's greater than 9. So we're good, but we can't stop. We've got to make sure that all sets are going to work. So 4 and 9 has to be greater than 6. 13 is greater than 6, yay! And then next set is 6 and 9. 6 and 9 has to be greater than the third side of 4. 15 is greater than 4. So when it turns out that any set of 2 is greater than the third, then my answer is yes, it's going to make a triangle. So let's see the next one. We take our two sides. 5 plus 7 must be greater than the third side of 12. 5 plus 7, that's 12. That is not a true statement. 12 is equal to 12, and that's not okay. We don't want it to be equal. It has to be actually greater than that third side. So I can go ahead and stop right now and just say no. If you had checked the other sides first, that's fine. But as soon as you find one combination that doesn't work, you're going to stop right there and just say, nope, can't make a triangle. So we know that every two sides has to be greater than the third. So sometimes I'm going to give you two of the three sides. And your job is going to be to find the third side or to find a range of values. So all possible values that it could be. So I have a side of 10, I have a side of 14, and then I have this unknown side of x. Since I don't know it, I give it a variable. But I do know that 10 and 14, that has to be greater than x. If it's going to form a triangle, two sides has to be greater than the third. 24 is greater than x. That was one combination. I'm going to try another combination. So 10 and x. 10 and x together have to be greater than the third side of 14. So I have my inequality. I want to solve for x. So I move the 10 over, and I get x is greater than 4. My last combination is then 14 and x had to be greater than 10. So 14 plus x must be greater than that third side of 10. I move the 14 over. I get x is greater than negative 4. Now that one's not very helpful because it does have to be greater than negative 4 because it can't be a negative number. So that didn't give me any helpful information. I ignore that. Our first piece is saying that 24 has to be greater than x. Why don't I flip that around there? See, the x has the little side next to it. If 24 is greater than x, that means x has to be less than 24. See how the smaller side is next to the x? It stays next to it. I then take those pieces and I'm going to put them together. So I know it has to be less than 24 and it has to be greater than 4. I put that in my range. 4 is less than x, which is less than 24. If you cover up the right-hand side, you see x is greater than 4. If you cover up the left-hand side, x is less than 24. So my values are anything between 4 and 24, but it can't be 4 and it can't be 24 because it doesn't say less than or equal to. Now, once we create our triangles, we look at the different sides of our triangles. So for example, if I looked at my first triangle, I had a side of 4, a side of 6, and a side of 9. I have different kinds of triangles based on what kind of sides they have and what kind of angles they have. And we're going to classify our angles based on sides and on angles. So if I'm looking at the sides of my triangle, if I have a scalene triangle, all sides are different. So scalene means that none of the three sides are the same. I have an isosceles triangle if I have two congruent sides. And I have an equilateral triangle if I have three congruent sides. Now I can't have four congruent sides because a triangle is three sides. So if none of the sides are the same, it's scalene, 2 is isosceles if 2 are congruent, and 3 congruent is equilateral. But then I look inside of my triangle and look at the relationship of the angles. For the angles, we have acute triangles, and that is when we have 3 acute angles. So just like a triangle has 3 sides, it also has 3 angles. If all 3 of those angles are acute, then it's an acute triangle. It's a right triangle if we have one 90-degree angle. The other two, both are going to end up being acute based on the angle restrictions. And it's an obtuse triangle if we have one obtuse angle. Last, we have an equiangular. Equiangular. And that is when all angles are congruent, and that only happens when they're all 60 degrees. All right, so that is it for today's video.